Hey guys, so what we were being asked here was to identify the roots, and I even gave you like i.e. the x-intercepts, plot the points, and write the solutions. So let's use green. I wanted to plot the points that cross the x-axis. So here and here, and then I'm going to use this tool, the T, which gives me a much easier way to write and write what x equals. Now you could just write the numbers. So it's where's it at? Okay, -1 and 3 for sure. That's one way to write it. I also want to show you that you can use the bubbly ones here. I call these butterflies. Not -1 and 3 and close that out. What you can't do, so I'm going to erase this, but is -1, 3 with parentheses around it because that's a point, right? We already measured points, right? We've plotted points, I should say, not measured. But either one of these here is an acceptable answer. So wherever you place that, that's cool. Okay, the next problem, where does it cross the x-axis? Okay, perfect. Let's use a bright red. So here and here, that's my equation. So what are my solutions? My solutions are x equals 2 and 4. Right? It could be written the other ways too with those fun butterfly brackets. Okay, this one's a little interesting because I only have right here one solution. So it only equals -4. So that's an interesting case where your vertex is the x-intercept. Okay, so the vertex is the x-intercept. Just in case you can't see that well, I'll put it in yellow. Right here, the vertex of it is also the x-intercept. So you'll find that the roots that happen sometimes. So there was only one root in this case. The past two, and most cases, we'll have two roots. But in this case, we only have one. And then lastly, this problem, I really wanted to see what you could do with this. The graph does not cross the x-axis. It's up here. And look where these arrows are going. They're going forever down. So there is no solution for this problem. Sorry, clicking out. There we go. So no solution for that one. All right, so I wanted to show you guys that, and then I wanted to kind of take this a little bit further so you understand a bit more. So if you could look at the board behind me, and we're going to take a little bit of notes. So guess what? We've been graphing to solve. So that was like a big reason why you need to learn how to graph first. And we're hoping that you're starting to grasp that concept and you'll have more practice between today and tomorrow to continue to graph. But now you're not just graphing, you're graphing because you're solving. The solutions, as you might have learned by now, they're your x-intercepts. So there's 4 ways that you can be asked for the same exact thing. The solutions, if they're looking for that, to find the x-intercepts means the same thing. And then these other names that you're going to see a lot more, they're actually like the most common way to be asked is to find the roots and identify the zeros. And that's because the zeros one is because when y is 0, you're on your x-axis. So the zeros, think of the y becomes the 0. Or just remember that no matter what, all 4 of these things mean the same thing. You have to find where the graph crosses the x-axis, and that's called an x-intercept. All right, so I want to show you an example of that. If you didn't get this down, pause it, hit play, and then we'll do the example together. Just one example, okay? Graph and identify the roots. Okay, so again, that means we're finding our x-intercept. Here's my equation, y equals x squared minus 2x plus 8. And we already learned how to graph, so I'm going to go through those steps a little quickly today. Step 1, let's move this down a tiny bit. Step 1 is to find that axis of symmetry. So the opposite of -6 is +6 over 2 times 1. Okay, now that could be another number. We just have been using 1 a lot. Trying to keep the numbers small since we're making graphs in our notebooks, so I know that it's easier for you to kind of stay close to that origin. Anyway, so 6 divided by 2 times 1 is 2, so 6 divided by 2 is 3. So if you notice here, I made a coordinate plane. Pause the video and make a coordinate plane. I wrote a dashed red line on when x equals 3. 1, 2, 3. If you want to put like a number somewhere, I'm going to put a 5 there. And then 1, 2, 3, 4, 5, a 5 there. Label this as y, label this as x, draw arrows to show that they do go further than that. And I only put a couple of points. Because I put a 5 here, that means these all have to be, because there's 4 tick marks before it, 1, 2, 3, 4, and then 5. So you don't have to write numbers on every single one. So anyway, I put a dashed line here at when x equals 3, right? That line, that vertical line, that's my axis symmetry. So that means the parabola is somewhere around that. It splits it right in the middle. All right, let's continue on. So now I need to find the vertex. So I'm plugging 3 into my equation. Y equals 3 squared, that's 9, minus 6 times 3, that's negative 18, plus 8. So mind you, this is a little messy because this is like your scrap work. It's okay to be a little messy as long as you understand your own writing and I can see it, right? Show me that. So if this were your work and you're like, oh, Mrs. Kane can't see it, then fix it. Not a big deal. Negative 9 minus 18 is negative 9, plus 8 gives me negative 1. So that means my vertex is 3, negative 1. Notice, from there I made a table of values and I placed 3, negative 1 in the middle. So I have to think, if here's 3, what are to the 2 numbers to the left of it? Oh, well, it's 2 and 1. And to the right of it, oh, that's 4 and 5. And those are the values that I'm going to quickly plug in and get so I can plot points. I can plot my vertex. That's 1 point I have. Positive 3, negative 1. Oh, there it is right there. That's plotted already. I did that already. So then 2 squared, that's 4. Right? So 2 squared, now I'm plugging in 2. That's 4. Negative 6 times 2, that's negative 12, plus 8. So 4 minus 12 is negative 8. And 8, negative 8 plus 8, oh, that's 0. So when I plug in 2, I get 0. And fun fact, and I hope you know this by now, because 4 is on the other side, it's that exact reflection, I'm going to get a point also right here for 0. All right, that's not working too well over the black, so let me try blue. Blue seems to be a good one. And now I'm plugging in 1 into my x values. 1 squared is 1. Negative 6 times 1 is negative 6. 1 minus 6 is negative 7, plus 8 is 1. So I have the point 1, 1 right here. And I know if I'm 2 away, then I also have 5, 1 because that's 2 away. So then I have a parabola. There's one other point I can plot. This 8 is my y-intercept. C is your y-intercept. So I don't really have 8 on my graph. It's somewhere up here. So just keeping that in mind when I draw my fabulous U through the directions. There we go. Now, that wasn't the point, right? It said to graph, that's part of it, but it said to identify the roots. So don't forget to do that. It's just like a nice little add-on. So the roots, fun little butterflies, where do I cross the axis? Well, you can see it on your table here when y is 0. So x equals 2 and 4. That's a horrible 2. 2 and 4. I look like a toddler wrote that. Okay, so 2 comma 4, just make sure it's not parentheses. As I told you, that looks like a point. And there we go. Hope that helped.